This is finding the molar mass is the grams. Anytime it says molar mass, it's how many grams are in a mole of anything. So it says the molar mass of carbon, that would be 12. If it says molar mass of a compound, then you've got to add everything up, multiply it out, and then add it up at the end. There's 12 days to mole day. Just want to let you know. You're counting down.
Is that the day we don't do anything?
Well, there's some things we'll do, but nothing related to school. Like eat cake and have ice cream. Juice.
We did pie day in John.
That's why I just said okay.
Well, we're gonna have mole day.
Can you get some mold? Or are you going to bring some molds in a cage? Yeah. That's what
No. I'm going to. That would be just one mole, and if I cut it in half, it'd be a half a mole. That wouldn't be good. Would I? Have a half a mole. Hey, I'll bring a half a mole.
We can play whack-a-mole.
I do have whack-a-mole. We'll have a little competition in whack-a-mole. So last year we didn't do it because we didn't get to chapter 7 with moles. I don't know why the layout of the... I like this book because they've got a variety of different ways they show you problems and they give you a bunch of examples to do and they get to the point, but we didn't get to moles until later on. Now, give you another minute. Now, having you guys memorize the symbols and the names should help you not have to look all over the periodic table to find a certain symbol. So this speeds up the process because when you're taking the test, you do not want to take a minute or two looking up a symbol on that table. You should familiarize yourself. Then a lot of the students, after a few days of doing these, they won't look carbon up anymore because they'll know it's 12.01. They won't look oxygen up anymore. They know it's 16. And some of you will get to that point, you won't look it up anymore because you know some of those, you know, what they are. And that's the nice thing about that. And so when we get to tests, we know students have worked these out because they do problems pretty quick. They don't take a lot of time looking things up. So here's the answer. Is that what you guys got?
Yep. Yeah.
Wait.
Oh, I forgot to add. Rats.
Huh?
03 is the okay value to have? Just rounding differences?
Yeah.
Yeah, because I read one more on.
That's okay. If you guys take it out further, I don't care. I just want at least to go the nearest 100th spot.
But then I rounded up to 200 squat. Now I have 3. So.
That's fine.
I did it right.
Okay, hey, this is 5 digits, and if I would use this in a question, you have 318.03 and I have 318.02, and then you do a calculation that has 2 significant digits in the answer. Do you think our answer is going to be any different? No. If you had 3 significant digits, let's say that we were coming up with as a difference, it's not going to be any difference. Okay, but you still need to take it out to at least the 100th spot, so it does give you enough room. If you take it out, take these out farther, each one of them, we'll come up with maybe a little different answer if you take yours out farther. But it won't be much. It's very minimal. Yes?
So like on a test for oxygen, you don't want us to do 15.9994?
No.
Okay.
Just be rounded up.
Yeah, because hey, I don't want you spending time taking it out as far as what's on the periodic table. and just like I said, if I was in a lab and I had to be more accurate and have, you know, more precision that I had to take account for, then I would take it out all that way. But we're not in that situation. So it's a fine line to how far to take it out. So we always are pretty successful when we take it out to the right. Okay, now, here's the transition, and you've done this problem before, but it's dealing with compounds, all right? So you've done this problem before. It's just dealing with compounds and how they work. So this is changing grams to moles. So you guys know how to change grams to moles. You did it on your quiz. It was number 1 and 2. Number 1 and 2 on your quiz, you did. The only difference is now I've got to do a little extra work in which to figure out a molar mass. I can't look at the periodic table and just get it and then just do the calculation. I have to do what? So if I want to find out how many moles of this I have, what do I need to do first?
Look up the masses of the CO2.
Yeah, and then add them up like we just did, and that's my molar mass. That's how many grams are in a mole for CO2. So every one of these you're going to have, that's why I did simple ones, every one of these I'm going to have to calculate. I got 1 carbon, and I'm going to do this a quick way, and you guys decide if there's something that you can do, especially with some of these smaller ones. That one is 12.01, and then this is 2, so that would be plus 2 times 16, which is 32, right? So what would be the mass?
44.01.
44.01. See how quick that was? All right? So that's how many grams are in a mole. Then what you do is you say, okay, I'm going to set it up. I'm going to go 40 grams CO2. Unit goes down here, grams of CO2. Goes up here, moles of CO2. Units 1, 2, 44.01. Okay? And I'm doing the exact same thing, but I have to find the molar mass. Questions? Got it? So we're doing the same process as what we did with atoms, but now we're doing it with molecules and number of grams per molecule. So that answer would be 0.909 moles of CO2. You guys do B. You guys do B and see what you come up with. So, on this one, a lot of people get to where they memorize these two also. They got those memorized because we use water and CO2 quite a bit in different cases. So, H2O is 18.01, right? Grams. 2 hydrogens, 1.01. So that would be 2.02, and then oxygen 16. Add those together, you get 18.02 grams per mole. So then all you're doing is you're taking 15.5 grams of H2O. And then down here you got grams of H2O, and up here you got moles of H2O. So this would be 18.02 to 1 mole. And then you got your You got your answer. Make sense? Yeah. So now we're counting molecules with moles. And it's a count. Okay, don't forget that unit, mole, is an actual amount of molecules and related to Avogadro's number. So that one would be 0.860 moles. Okay? All right, and well, I think we'll just do one of these next ones unless you want to do the second one and I can show you. So we're just going to do one more of these. So now, and let's do the second one. So now I'm going to have you guys do this on your own and see what you come up with instead of me doing it. So now we're going to want to find out how many grams you'd have in that number of moles of NH3. So if you go ahead and do that calculation. Hello? I will. Uh-huh. I need to go down to the office. I don't know. I don't think you'll be down there the whole time. So you just run down. So this is day 4 of this, doing this moles and molecules and atoms and grams and going back and forth. And it's just converting. And it's just making sure you've got the right unit with the correct number when you do that conversions. On most of these, not all of them, most of these, moles is going to be 1. Especially if you're going from grams to moles and moles to grams. Okay? The grams are going to be off the periodic table if it's an element, or you're going to do the calculation of it by using those weights to get a mole of a compound. Okay? Now, tomorrow we're going to look at doing percent composition by mass. And doing percent composition by mass is just an extension of finding the molar mass. So it's just one more step after you find the molar mass. Okay? That's all you're going to do. Next week, we get the opportunity toward the end of next week, I think on Thursday, because we don't have school Friday, you're going to do a lab and you're going to find you're going to find a chemical formula based upon a chemical reaction of elements. Okay? And we'll do that on Thursday next week. Okay? That we'll do that. So, this should be really easy. You got 1 nitrogen is 14.01 plus 3 times 1.01. So, that's going to be 17.04. That's okay. I can show that one later. Okay? So, 0.795 moles of NH3. Moles of NH3 to grams. And that would be, for every 1 mole, you have 17.04 grams. And you got your answer. Okay, if you did this one, then I'm going to give you guys your assignment so you guys have at least 15 minutes to work on that. So your assignment's just 6 problems, and it's doing these, each one of the problems we did today a couple times. That's all you're doing. There's a lot more that I could give you, but I think that would be sufficient to get down what you need. So that answer is 13.5 grams. Okay, if you did this first one, it would be aluminum's 26.98 plus 3 times 35.45. And then you get your weight, and then you go ahead and...
It's like 133.33.
So 1.93 moles of AlCl3. Down here to go 1 mole the ALCL3, and you said it was 133. Point what? 33. Okay, and then you would go ahead and get your answer for that. So here's the assignment that I figure you guys could do. Let me find it. I wrote it down somewhere. Okay, it's page 201. And it's B and C. Okay, this is, next one's page 205. And it's CD for 22. Okay, give you more information. 12, B and C, 22, C and D, and 26, C and D. Okay, this is going to be a completion. There's 6 of them. If you want to put them in your notes, that's fine. But that's all you're going to be doing. So on 201, you're finding molar mass. 22, you're using molar mass. And 26, you're using molar mass to find grams or moles. Okay? You might be able to get done with most of it before you go. No, this is going to be in your notes. You can put it in your notes or put it on a sheet. It's a completion rate. Okay? Come around and look at your answers tomorrow, and if everybody's getting majority of them right, then we'll move on and do what's called percent composition. Yeah, the assignment, if you need to work on your assignment to finish that up for today, then I would focus on that. If it's done, you can go ahead and put it in the tray. Okay? So assignment, let's do today for grading. Turn it in the tray. If you're not done with that, you've still got about 15 minutes. You can work on that. Get it done.